In April 2025, NASA issued yet another warning. A filament eruption on the Sun is expected to launch a massive wave of charged particles toward Earth, triggering a solar storm. This year marks the peak of the solar cycle, raising growing concern among scientists and the public alike. Could this finally be the long-anticipated horror storm? If so, it could throw our modern civilization into darkness within minutes, unleashing widespread chaos and damage. As we approach the height of solar activity in April 2025, a G2 level geomagnetic storm warning has been issued. The alert stems from a coronal mass ejection linked to a filament eruption, first detected by astronomers in mid-April. This powerful ejection is sending high-energy particles hurtling toward Earth, with the potential to disrupt systems here in the days and weeks ahead. Such a strong event may also signal more intense solar activity to come, increasing the likelihood of further, possibly more destructive, storms on the horizon. Sunspot activity is raising serious concerns. What can we realistically expect in April, and what might the rest of the year hold? Right now, the Sun is highly active, with the current sunspot count reaching worrisome levels. And yet, we haven't even hit the peak of this solar cycle. That won't occur until sometime between May and late summer of 2025. Already, we've witnessed around a dozen intense X-ray flares, some ranking among the most powerful ever recorded. In addition, multiple M-class flares, major filament eruptions, and subsequent coronal mass ejections have driven proton levels to extreme highs. Over the past year, much of this solar activity has surpassed established warning thresholds. To put it simply, Earth has been enduring a relentless bombardment of solar particles, something not seen since the beginning of modern solar monitoring. This surge began with a notable event on September 15, 2023. Back then, a coronal mass ejection marked the onset of the current peak in solar activity. The plasma cloud released during that event took a few days to reach Earth, where it sparked a moderate geomagnetic storm along with some noticeable disturbances. Officially, it was classified as a G2 level geomagnetic event, similar in strength to the storm we're currently experiencing in April 2025. At this level, the effects are still considered moderate. The G2 storm in 2023 led to dazzling auroras visible across several U.S. states, including Alaska, Montana, North Dakota, Minnesota, Wisconsin, Michigan, Maine, and New Hampshire. While it also caused some minor issues, brief communication outages, radio signal interference, and short-lived GPS failures, these were quickly resolved with minimal impact. But what if a much stronger storm were to strike? One that disrupts key systems not for minutes, but for hours or even days. We could see widespread compass anomalies, prolonged blackouts, and even animals behaving erratically. Imagine a world where the power grid fails for days, cell phones go silent, and disoriented birds fall from the sky. That's the kind of chaos a long-anticipated superstorm could unleash. The list of potential dangers is extensive, ranging from navigation issues due to compass inaccuracies and GPS deviations of up to 10 meters, to power outages caused by transformer failures. Satellite communications could be severely disrupted, leading to widespread breakdowns in television and radio broadcasts, radio communications, and navigation systems in cars, ships, and, in the worst-case scenario, even airplanes. The resulting chaos in air travel could be devastating. Airlines might be forced to cancel flights on a massive scale at the first sign of serious interference, while planes already in the air could be ordered to make emergency landings at the nearest available airports. But the impact wouldn't stop there. Some researchers warn that wildlife could be deeply affected. Many animals rely on Earth's magnetic field for navigation. Birds, fish, bees, whales, and countless others could lose their sense of direction. Disoriented foxes and wild boars might wander into urban areas, while flocks of birds could crash land en masse, later congregating on roads, in parks, and in other unexpected places. The scenario echoes scenes from Hitchcock's The Birds and other apocalyptic tales. Although such chaos might only last a few days, the full extent of the damage would be difficult to predict, and potentially severe. Power outages can have severe consequences, particularly for security systems and food supply chains. ATMs might become inoperable, and access to shopping facilities could be significantly restricted. The full extent of the impact from a major storm is difficult to predict. We've never faced such an event before, and it's unclear how reliable our backup systems, like emergency power generators, truly are. Experts have also highlighted another serious risk: powerful induced electrical currents. These can overload transformers, trigger short circuits, or even start fires, especially in areas where electrical infrastructure doesn't meet strict safety standards, as is often the case in parts of Europe. History offers a stark warning. In 1989, a relatively moderate geomagnetic storm caused a blackout in Quebec, Canada, knocking out power for 6 million people over a span of 9 hours. And during the Carrington event of the 19th century, the early global telegraph network collapsed, wires melted, equipment sparked, and some systems even caught fire. In the modern world, one of the greatest threats we face is the financial cost of space weather. Even brief satellite outages can cause billions of dollars in damage. Disruptions to weather forecasting, navigation systems, and communication satellites alone could rack up losses in the hundreds of millions. During intense solar storms, airlines may be forced to reroute flights over the equator, an adjustment that could push already struggling carriers to the edge of bankruptcy. A powerful historical reference point is the Carrington event of 1859. At the time, few could have anticipated what was coming. People were just beginning to adapt to the revolutionary electric telegraph system. Electrical engineering was in its early stages, but the ability to send messages almost instantly across continents marked the dawn of global communication, a true beginning of the modern communications era. Back then, scientists were already observing the sun, but the links between solar activity, Earth's magnetic field, the auroras, and the nascent power grid were still largely unknown. Electric current has driven human progress and helped shape the culture we experience today. The Carrington event is now regarded as a stark warning for humanity. It all started when auroras appeared in parts of the northern hemisphere where they are rarely seen. Eyewitnesses described the sky as if it were on fire. The U.S. Midwest was hit especially hard. Telegraph equipment suddenly sparked, and some devices began operating on their own, almost as if by magic. In those areas, people feared it was a supernatural occurrence. Sparks ignited papers, and telegraph lines buzzed and crackled mysteriously, leading many to suspect faults or power surges in the electrical grid. But what was the real cause? Normally, Earth's magnetic field deflects electrically charged particles from the sun, capturing them in a protective shield. How threatened is Earth's magnetic field? Did you know that our very existence depends, in large part, on this invisible shield? Without it, we wouldn't have a protective atmosphere, tides, climate, or even electricity as we know it. Earth's magnetic field plays a crucial role in creating the perfect conditions for life and the rich biodiversity we see today. Although we rely on it in many ways, scientists are still uncovering the full extent of its impact. For example, many animals navigate using its magnetic lines, and it likely helps retain vital moisture in our atmosphere. However, it remains uncertain how much human biology depends on it. In contrast, Mars has almost no magnetic field, which is thought to be why it lost most of its atmosphere. If Earth ever had an atmosphere that was lost, it likely resulted in the disappearance of all surface water, leaving the planet barren. It's truly remarkable what our planet's magnetic field accomplishes. This magnetic field is created by a delicate balance of forces deep within the Earth. Our planet's geodynamo is powered by the rotation of liquid metals in its core. The process involves Earth's rotation and the complex interactions between solid and liquid metallic layers. Convection currents cause the molten metal to move much like boiling water, and the flow of liquid iron generates electric currents that produce our magnetic field. This field wraps around the Earth, resembling a giant bar magnet with poles at the magnetic north and south. Everything works almost flawlessly: the rotation, the liquid movements inside, and the protective magnetic pockets near the poles are perfectly synchronized. However, there are exceptions, and these can pose risks to us.